Hi friends, this is Kaushik. So in this video today I'm going to explain you about recent trends in database. So all of you know that what is a database. So let me tell you in a short manner. Database, what is database? Database management system is a system in which related data is stored in an efficient and compact manner. Here, efficient data. Efficient means data which is stored in the DBMS is accessed in very quick time. Compact means that the data which is stored in database covers very little space the computer's memory. Related data, the data which is stored in the DBMS is about some particular topic. We are going to the next slide. A database is a set of software programs that controls the organization, storage, management, retrieval of data in a database. So the database accepts requests from the data from an application program and instructs the operating system to transfer the appropriate data. A large systems such as a database allows user and other software to store the retrieved data in a structured way. Many database packages provide fourth generation programming languages and other application development features. Database servers. Database servers are computers that hold the actual databases and run only the DBMS and related software. So database servers are usually multiprocessor computers with a generous memory and a RAID disk arrays used for stable storage. So let us now see the history of DBMS. In 1960, first DBMS by Charles Beckman at the IBMS Information Management System. And next in 1970, EF Pod introduced the Relational Database Management System. Later in 1980, relational model became popular and accepted as a main database paradigm, SQL, ANSI, SQL, etc. Later in 1980 to 1990, new data models like ODBMS, ORDBMS, powerful query languages, etc. Popular vendors are Oracle, SQL servers, IBM, DB2, Informix, etc. came into the industry. Now let us discuss why is changing trends, which is the main mode of this video, right? So difficulties with RDMS storage and usage, demand for data in form of other than just text. Adoption of e-business causes rise in online DBMS capacity demand. Growth in e-commerce and enterprises portals creates market for open source DBMS. Demand for access through mobile devices, mobile data suits. What are the current trends? So as you are seeing in the screen, multimedia database, distributed database, document-oriented database, mobile and embedded databases. These are the four current trends in the database right now. So let us see one by one. So the first one is multimedia database. Multimedia database means typically divided into four types: digital images, audio, video, animation, and graphics. The generation, storage, processing of multimedia data in computers and transmission over networks have grown tremendously in the recent times. So, the contents of the multimedia database. Multimedia. First one, multimedia. The actual data representing images, audio, video that are captured, digitalized, and processed, compressed, and stored. Next one is multimedia format data. Contains information pertaining to that format of data after it goes through a acquisition, processing, and encoding phases. Example like sampling rate, resolution, frame rate, encoding schema, etc. comes into this media format data. Next, media keyword data, which is content descriptive data. This is called as a content descriptive data. Contains keyword descriptives relating to the generation of the media data. Example for a video includes the data, time, place of recording, person who recorded, scene that is being recorded, etc. For example, this video is example for this media keyword data, as it stores all the data, time, place, recording name of the person. So we're going to the next slide. Next, media feature data. This is content dependent data and contains the features derived from the media data. A feature characterizes the media contents. Example, info about the distribution of colors, the kind of textures, and the different shapes present in an image. Varying parameters. The media keyword data and media feature data are used as indices for searching purpose. The media format data is used to present the retrieved information. It is used to retrieve the information that is being used in this media keyword data and media feature data. So in this diagram, it shows that a multimedia database. This is a reference architecture. So here, when a multimedia query interface is acted, when a query is passed to get a record text, or images, or audio, or video. Query is passed through the query processing media composition integration metamatters, which is present in the middle, as you can see that. So later that it goes to the text GBMS or image based on the query. It goes to if want to search it in images or audio or video or in text form. Based on that, it goes to the separate database management and it gets the information to the user. Multimedia database. Some examples: multimedia search engines like multimedia.lycos.com. This is one of the site for multimedia search engines. Next, search engine for sounds, which colors some different kinds of sounds. Only the sounds are present in this database. No other no other data is present in it. So findsounds.com is example for search engine for sounds. Next, image search. Already we know that Google is the best example for image search. Applications of multimedia database: streaming data, interactive video, digital libraries, image retrieval. These are the four main applications of multimedia database. So let us see one by one. First one, streaming data. Data stream, data streaming, used generally in electronics, telecommunications, communication architecture. They require bandwidth, time dependent, no time lag, source and sync. Next, going to streaming data. Mode of transmission. The mode of transmission for the streaming data is asynchronous, synchronous, or asynchronous. Isochronous. Characteristics. Time is the main characteristics for the streaming data. Strongly periodic, weekly periodic, variable of consecutive packet amount, strongly regular, weekly regular, irregular continuity, connected data streams, unconnected data streams. They are present in the streaming data as you see in the PDF. Next, multimedia databases. Second application is interactive video. The term interactive video usually refers to a technique used to blend interaction and a linear film or video. So here the base example is YouTube. As everyone is aware with the YouTube, so it is the best example for the interactive video, which shows the data of any particular interactive video that is being present in it. It contains only the video format data. Okay, so let us see in a simple manner. Interactive video in YouTube. Here you can see in the search bar that interactive video shows that a day at Disney World. It is an interaction video which shows what is that person's interaction at the Disney's World. So it tells the so it shows us the interaction videos which is being present as video. So YouTube is the best example for this interaction video. Next, digital libraries. Collections are stored. in digital formats, not as print or other media. So this is mainly used to store the data in digital format, that is as photos, etc. That like that. The digital content may be stored locally or accessed remotely via computers networks. A digital library is a type of information retrieval system. So the best examples are Google Book Search and World Digital Library, which shows the books, etc. The information which you want, we can get through the Google. World Digital Library, as you can see in the screen, that World Digital Library at the rate US Library of Congress, Washington DC. It shows that the libraries which are present in the world are very famous and items which are present in it. As you can see on the screen. Next, the fourth application is a image retrieval. Here you can see that the search engine that item is item is given in the query, so it shows the here everything here you kept a filter that only images. So the, the query which is given in the ITM, it shows only the images of the ITM. What is ITM? What is ITM? Different types of ITMs shows only the images. As the given filter that only images shows that, so this is an image application. Next, distributed databases. A distributed database is a collection of multiple logical interrelated database of the same system distributed over various sites of a computer network. Sometimes the distributed database system is used to refer jointly to the distributed database and the distributed DBMS. Aspects of distributed database. So first one is distribution. Data are not resident at the same site, so that we can distinguish or distribute database from a single or centralized database. Logical correlation. Data have some properties which tie them together so that we can distinguish a distributed database from a set of local databases or files which are resident at different sites of a computer network. So here this shows, so in this video, as you can see on the screen, that is a distributed database diagram. Here on site 1, site 2, site 3, site 4 are getting a request from the computer network. As it receives the request from computer network, site 1 goes to the database 1, site 2 goes to database 2, site 3 goes to database 3, site 4 goes to database 4. So here in the query, so in this distributed database, the query is distributed in different sites. So this is called distributed database. Examples of distributed database are cloud computing services. All major social and professional networking sites use the distributed databases like Facebook, etc. uses the distributed database. Document-oriented database. Each record document might have a different format, number, and size of fields. Don't store data in tables with uniform size of fields of each record. Instead, each record is stored as a document that has certain characteristics. Any number of fields of any length can be added to a document. Fields can also contain multiple pieces of data. Document-oriented, the next one is document-oriented database. So here we can see that the coding is given such that to store the document, there is a person's name. As we can see in the first example, the document, first name Anna, address Denver, hobby singing. So like this we can like this we can store the data of any person in text form. So this is a document oriented database which we can store our data using these commands. So another example is first name Anurag, address Train, hobby dancing, nickname Mishra. So like this we can make data in document form and we can store and we can retrieve it whenever we need it. Next, all XML databases are doc-oriented databases. As we all know that XML databases are only the doc-oriented databases. Apache's CoachDB is an example of free and open source document-oriented database. There are various other such providers. Next one is the mobile and embedded database. Many daily uses devices contain database. TV, washing machine, mobile phones, etc. Example, Android phones with SQL side database. As we can see nowadays, everyone is having a smartphone. With a smartphone, we can use it to we are able to use the Google, Amazon, which is a big database. So with this, so with the help of the mobile, we are able to fulfill our queries, etc. Next one, embedded database in cars, airplanes, etc. Nowadays, cars are coming with their self-infotainment system. Like they can manage everything. They can maintain the cruise control. That they can maintain the climate control, etc. Everything is within the car. So the database is being used not only in mobile phones, that also in cars and airplanes, manage configurations and store sensor data. Example, DB40 object database used in BMW car IT system. The database which is used in BMW car data is highly valuable for every business organization. The trend just depict mere examples of what is stored for us in the future. So, thank you.